I have already discussed with you the pre-order traversal of a binary tree. Now this is an explanation of how the non-recursive pre-order algorithm works. Now before we discuss the algorithm, let us see how one node of a binary tree is represented. This particular structure is used to represent one node of a binary tree. Now, if you remember singly linked list that we have covered in class, this is one node of a singly linked list that contains a data part and an address part, and this address part stores the address of the next node of a singly linked list, correct? So one node contains a data part and an address part that stores the address of the next node of a singly linked list. Similarly, if you compare these two structures, a node of a binary tree contains a data part and two address parts. One address part storing the address of the left child of the node, another address part storing the address of the right child of the node. So this is the structure of the node. It has got three parts: data part, address of the left child, and address of the right child. Clear? Now coming to the algorithm over here. The pre-order algorithm is called with the root of the tree. Now let us assume this is the binary tree. So when you call the pre-order algorithm, you are going to call the pre-order algorithm with the root node, that is 20 over here. This is the root node. Now in this algorithm, we have defined an array that is going to act as a stack. An array of 100 nodes that is going to act as a stack. So you see, we have defined the stack as the struct bin tree type. That means each element of the stack will represent one node of the binary tree. Each element of the stack will be of the binary node type. Then the top has been defined as -1 and flag as 1. Now you see we have implemented stack over here, and you know when the stack is empty, the top is always initialized to -1 to show that the stack is empty. Now let us start with the algorithm. While root not equals to null. So you see over here our root is 20, so it is not null. So you enter the while loop, visit root data. Now, as we have discussed, visit means either you display the value, you count the value, search the value, any work you have on the value of the node, you do it in the visit portion. So for us, visit means to display. So we will display the value of the node. So 20 is displayed, right? Top is equals to top plus 1. So over here, top is initially -1. So when you say top is equals to top plus 1, top becomes 0. Right? Now, stack top is equals to root. So what is happening? In the stack top, what is the value of top? 0. In the stack 0, you store the value of the root. What is our current root? Our current root is 20. So you store the node 20. Now when you are storing the node 20, it actually means you are storing the value 20 and you are storing the address of left child of 20 and address of right child of 20. So when you are storing the node 20, you are storing the value, the address of the left child and address of the right child. All these three information in your stack. Clear? Now, next line. Root is equals to root left. Now, this is the root, that is 20. So when you say root is equals to root left. That means you are trying to access 20 left. Now what is basically 20 left? 20 left is nothing but 21 over here. Correct? So the current value of your root becomes the node 21. So again the loop runs. 21 not equals to null, that is true. Again you enter the while condition, visit root data. That means again you display the value of the root, that is 21. Next, top is equals to top plus 1. So over here your top value was 0. So your top becomes 1. And in stack top, that is stack 1, you store the node 21. You store the node 21. Again, storing the node 21 means you store the value of 21, address of the left child on 21 and address of right child of 21. So storing the node 21 means you are storing the value of 21. You are storing the address of left child of 21 and you are storing the address of right child of 21. Correct? Next, root is equals to root left. So when you write root is equals to root left, again you are trying to access 21 left. So 21 left over here is 24. So this gives you 24. Correct? Now, again the loop runs. 24 not equals to null is true. You enter the while condition, visit root data. So again 24 is printed. After that top is equals to top plus 1. So the top value over here is 1. So top value becomes 2. Top plus 1. And what do you do over here? Stack top is equals to root. So in stack top, that is in stack 2, you store the node 24. You store the node 24. Again, storing the node 24 means value 24, address of left child of 24, address of right child of 24. All these informations are stored together. Clear? Now, next, root is equals to root left. Now, this is important. Now, when you are trying to access 24 left and assign it to the value of root, when you are writing root is equals to root left, that is 24 left is nothing but null over here. So 24 left means the root becomes null. Correct? So now when the while loop is running, root not equals to null becomes false. So you come out of the loop and come to the if condition. If top not equals to -1. Now let us inspect the value of top. The value of the top currently is 2. So top not equals to -1 is true over here. So you enter the if condition. Root is equals to stack top. Now, what is this portion doing basically? You see, we already know that pre-order traversal means VLR. As soon as you have got a root value, first you have visited it. That means you have displayed the value of the root. And then you have traversed the left side of the root. Now, after traversing the left side of the root, you have put the root into a stack. So, as we have traversed 20, we have visited 20 and we have come to the left side of 20. We have put this 20 onto a stack. When we have come to 21, we have visited 21, we have put it onto a stack and we have come to the left side of 21. We have come to 24, we have visited 24 and we have come to the left side of 24 and we have seen that left side of 24 is null. Now according to pre-order traversal, now we have to go to the right side of 24. So to go to the right side of 24, what we are doing is, first we are popping it from the stack and we are making it the root again. You make 24 the root again. So since 24 is on the stack top, 24 becomes your root. 24 becomes the root again. Now what do? Top is equals to top minus 1. So top becomes 1 because you have said top is equals to top minus 1. So top becomes 1. And then you go to the right side of the root. So root at present is 24. So you go to the right side of 24. Root is equals to root right. So you go to the right side of the root. Now you see, when you are trying to access 24 right, 24 right is also nothing but null. Correct? 24 right is nothing but null. So over here you get the root value as null. Right? Now you come out of the if condition. Since you have already worked with if, the else does not work. You come over here, while flag. Now you see the flag was already set to 1 and we have not changed flag anywhere in our program. So flag 1, so while 1 it is true, so you go back and you enter while root not is equals to null. But currently our root is null because we are on the right hand side of 24. So root not equals to null becomes false. You come out of the while condition and you come to the if. If top not equals to minus 1. What is our current value of top? 1. So top not equals to minus 1 is true. So you enter the if condition. Root is equals to stack top. Now when you say root is equals to stack top, that means root is equals to stack 1. Now what is there in stack 1? In stack 1 currently we have stored the node 21. Means all these information about 21 is at stack 1. So root is equals to stack 1. So now you are over here, you are at 21. Now top is equals to top minus 1. So from here again you say top is equals to top minus 1. So top becomes 0. Correct? Next, root is equals to root right. So you are trying to go root at current is 21 and you are trying to go to root right. That means 21 right. Now what is there in 21 right? In the 21 right you have got 26. So this is 26. Correct? Now else part will not be executed because we have already executed the if condition. You come over here, while flag. So flag value is again 1. So you go back while root not is equals to null. Now currently our root is 26. So it is not equals to null. It is true. So you come, enter the while condition, visit root data. So you visit 26. You visit the value of 26. Now after visiting the value of 26, you increase the top by 1 and put the root in stack top. So over here, top becomes top plus 1. So when top becomes top plus 1, top becomes 1 again. And in the stack 1, currently you store the node 26. So again, storing the node 26 means value of 26, address of left child of 26, address of right child of 26. Root is equals to root left. So what you want to do? You want to go to 26 left. Now what is 26 left? 26 left is nothing but null. Correct? So when you go back to the while condition, root not is equals to null is false because currently your root is null. You come out of that while condition if top not equals to -1. Now what is the current value of top? 1. So top not equals to -1 is true. So what do? Root is equals to stack top. What is there at stack top? Node 26. So root becomes node 26 again, right? Top is equals to top -1. So as soon as you pop from the stack, your top becomes top -1. So top becomes 0, right? Now root is equals to root right. So you want to go to 26 right. Now what is there on the 26 right? 26 right is nothing but null. Correct? So if condition is done, else will not be performed. You come to while 1 again, flag has not changed anywhere. So while 1 is always true. You go back to the do loop, you enter while root not is equals to null. But current value of root is null because 26 right is null. So current value of root is null. So this while loop is not performed. You come to the if condition. If top not equals to -1. So let's see what is the current value of top. Current value of top is 0. So it is not equals to -1. That is true. So root is equals to stack top. So root is equals to stack top. Now root is equals to stack top. What is the value of top? 0. So what is stack 0? If you look at our listing, stack 0 is node 20. So we have come back to node 20 after traversing the whole left hand side of 20. So currently our root becomes node 20. Correct? Now after that again, while flag is still 1, so you go back while root not is so top is equals to top -1. Sorry. So root is equals to stack top. So root becomes 20. Then top is equals to top -1. So top is equals to top -1. So over here top -1, top becomes -1. You see, top becomes -1 over here. Root is equals to root right. So over here we are at 20 and root is equals to root right. So we are trying to set root as root right. Now when you want to set root is equals to root right, 20 right is nothing but 30, right? So you come to 30. Now if condition is done, else part will not be executed. While flag, while 1, flag value is still 1. So you go back while root not is equals to null. Now 30 is not is equals to null. So you enter visit root data. So 30 will be printed. Top is equals to top plus 1. Now top over here has become -1. So when you say top plus 1, top becomes 0 over here and you store node 30. That means value 30, left child of 30, right child of 30. Root is equals to root left. So you come to the left hand side of 30. Now 30 left is null, correct? So when you are coming to 30 left, your root is becoming null. So while loop will not run anymore, it will come to the if condition. If top not equals to -1. Now you see currently my top is 0. So top not equals to -1 is true. You will enter root is equals to stack top. So root becomes 30 again. Root is equals to stack top. Let me write it down over here. Root is equals to stack top. Now what is the value of top right at this moment? Top value is 0. And what is there in the stack top? Node 30. So root becomes node 30. Now after that, top is equals to top minus 1. So top becomes minus 1. Top becomes minus 1. Top minus 1. Top becomes minus 1. Now root is equals to root right. So root is equals to root right. Currently your root is node 30 and root right is 40. So when you are trying to access root right, that means now your root becomes node 40. Clear? Now this if is done. Again while flag value is 1, you go back. 40 not equals to null, that is true. So you visit the value of 40. The value of 40 is printed. Top is equals to top plus 1. Over here top value is minus 1. So top becomes top plus 1. So top becomes 0. And you store stack 0 as node 40. Correct? Now root is equals to root left. You see left hand side of 40 is null. This while condition will not work anymore. You will come out. Top not equals to minus 1. Top value is 0. So obviously it is not equals to minus 1. So root is equals to stack top. Again your root will become node 40 because at this moment in the stack top you have the node 40. Top is equals to top minus 1. So top becomes minus 1 because currently top value is 0. So top is equals to top minus 1 means top becomes minus 1. Root is equals to root right. Now 40 right is again null. 40 right is again null. So again while flag you go back. This while loop will not run because root at present is null. You will come out of the while condition if top not equals to minus 1. But over here top is minus 1. So this if condition will not work. You will come to the else part. You will set the value of flag as 0 in the else part. And now when you come to this exit while will become false and your pre-order traversal will end. So you see, you get this pre-order traversal 20, 21, 24, 26, 30 and 40. So when you are not using the recursive method of pre-order traversal but you are using the non-recursive method of pre-order traversal, basically you use the concept of stack to implement the pre-order traversal technique using non-recursive method.